Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
Good afternoon, dear faculty members. I hope my voice is audible to everyone. Gaurav sir, is I'm audible?
Yes, yes, ma'am. You're audible.
Yes, sir. You can take over the class, sir. You can start for the day.
Okay, thank you so much. Just give me a second. Is my screen visible to all of you?
Yes, sir. It is visible.
Okay, thank you. So let's start. Yesterday we have gone through various topics, right? Let's revise the all previous topics we have covered so far yesterday, and let's go through the topics related to the nodes we have covered. How many types of nodes we have the idea about. So we have the topic related to node, full node, mining node, validator node we have covered, RPC node we have covered, archival node we have covered. So yes, in yesterday's class we have gone through how these nodes are interacting with the blockchains and how it is interacting with the users using any dApp or any kind of applications, and what are the various characteristics and the functionality of these nodes, right? So in today's session, we will cover another topic that is related to another consensus mechanism, which is nothing but a problem which was arised in like very early of the digital networking scenario. So it's a Byzantine problem, right? So many of you might have heard about this Byzantine problem, uh, where uh, where it's a problem where the generals are also known as a two general problem, right? So in two general problems, what does it mean actually? So where a user sorry not user where a king has established so many generals into their army, and he wants to like cover this he just wanted to cover this fort or the area. So Byzantine problem is related to communication in between the communication and trust problem in distributed system, where some nodes might act and maliciously send conflicting or incorrect messages, right? So this problem arises where it is inspired by the same kind of the scenario where suppose these are the generals and wanted to conquer this fort, and but the king has ordered them all to attack this particular place, this fort, at the same time, right? So when they arrived nearby this fort, they just wanted to be get confirmation to be prepared to attack this particular fort. And in order to fulfill that, what they do, they transfer some messages through messenger. In ancient time, whatever the messengers medium was there, so they send us some messenger from place one, this place to this place, and from this place to this place, so that they can acknowledge and receive the messages, right? But what the problem here is in Byzantine problem, this message, whatever has, whatever message has been sent by this general to this one, so this message can be tampered or can be lost, or this messenger can be like become a traitor and may like change the actual message what he has sent, right? So the reliability and the trust was the issue in between to fulfill the this entire operation. So Byzantine problem is related to same in decentralized terms in blockchain analogy or blockchain ecosystem. So it is a problem related to communication and trust, right? Problem in distributed system where some nodes, node participants might act maliciously, just like this one, and send conflicting or incorrect messages, or to fail completely to acknowledge or to respond, right? In within time period or within time frame, and the system must still be able to function correctly, reach agreement consensus. So this BFT Byzantine problem comes across where in decentralized manner we have to also follow this same scenario. This is where Byzantine fault tolerance kind of methodology has been developed by the engineers or the researchers. So what BFT means is Byzantine fault tolerance, right? So Byzantine fault tolerance is the mechanism, right, where we are handling the faulty nodes at the same time to fulfill any kind of operation, right? So let's suppose here we have three generals and they wanted to attack particular that uh, fort or place and to conquer that area, right? So in order to fulfill communication, what could be the scenario in between then, in between three of in three between of them, right? So A send a message to B, let's attack, and B also acknowledge the same message and said that let's attack, right? And the same with the C, and the C with A, and B with C, right? Vice versa. So imagine multiple generals of the Byzantine army camped around a city must coordinate an attack at the same time. However, some generals may be traitor or their message may get lost or altered, right? So what the challenge here? So challenge is some general may send false or intentionally like kind of the wrong messages. So let's say here the example of the C. So C is communicating to A and C is also communicating to B. But here the both messages are different. To A, he's saying let's retreat, and to B, he's saying let's attack. So in this scenario, this C is a traitor or a C is a malicious node in decentralized world, and who wants to tamper the data and who wants to change the actual data in the block or in the network, right? So on how the honest generals agree on the common place, a common plan, right? Attack or retreat, even if some general is lie on or don't reply. So suppose he is not replying and they all have to attack the fort or that area. Suppose let's say 6 p.m. or 6 a.m. in morning, but he is not responding, the C is not responding, or if this node or this general is responding in other way, right? They wants to attack, but it is sending some messages the different to the other one, right? So the dilemma is, if one general says attack at dawn, right, in morning or in evening, and other says retreat now, how can they trust the messages? If even one general lies, the entire army may fail due to lack of agreement, right? So this is a Byzantine problem, lack of trust in decent distributed environment with faulty or malicious sectors, right? So that's how Byzantine problems comes into. Now how it works, let's understand. So here, a node called a proposer or a leader propose a new block containing transaction. Suppose I'm a, proposer or a leader wants to add data into my blockchain, right? So I propose this transaction or ADA to be added, right? So I propose a transaction to be added. The next step is the block is sent or broadcasted to other nodes in the network for validation. So whatever I have proposed, that I have to broadcast that message to that particular network, to the peer members, to all the members of the blockchain network, right? Uh, to get the validation from the all the members, to get the majority or the 51% criteria to be fulfilled out, right? Each node independently verifies my transactions validations, and they validates my transaction or the block whatever I wanted to add into a network, right? So each node independently works. The next step is to each node votes for whether the block is valid or not, right? So suppose in that network where I have proposed to add a block into a network, uh, let's say 100 members are there in that network, right? And out of that 100, everyone is voting to, like, let's say 70 nodes or 70 members are saying yes, this transaction is valid, and this transaction has to be added into a block and then ultimately into a blockchain. But 30 person or 25%, so let's say 20% or 20 members are saying that, oh, no, this transaction is not valid, and then there has not this transaction or the block should not be added into a blockchain. And rest 10 members are not replying, or they are not online at that time when they are proposing the nodes to be added, right? So here the majority is saying yes, and 20 members are saying no, and 10% are not responding, right? So the scenario here becomes, if enough, right, enough number of nodes agree, the block is considered, so that the so majority is achieved, right? But in this BFT consensus, the majority is usually the two-third of the network. So whatever the network is, whatever the amount of members are involving in this consensus mechanism, so two-third has to be achieved while agreeing on a particular transactions validation. Suppose only, let's say, 100 members are there into a member into that particular network, but only at that time, let's say only 50 are present or 50 are online at that time. So two-third of that entire population of the entire number of the nodes has to agree to add a block into a blockchain, right? So this is the basic criteria to in BFT to add the data into a block and ultimately into a blockchain. Suppose if some nodes send wrong message or don't respond, right, the honest nodes can ignore them and still reach to consensus. So as long as more than two-third are honest, the system work correctly. But it's also a drawback kind of thing, where if two-third of the members are malicious or not responding, right? So they can hamper or they can tamper the data within the network, and that data can be like lost or changed or like some kind of deleted kind of formation, or the states will achieve by the data. So what was so this was the basic problem related with that. Now we have come up with the another solution where we have enhanced this functionality and achieve another thing into another mechanism, is known as practical Byzantine fault tolerance. So it is an enhanced version or of BFT. So that's why it is called as a PBFT, practical Byzantine fault tolerance. Let me know whether I'm my speed is correct or not. I'm audible or not. Uh, and if you have any kind of doubt or questions related with this BFT, please let me know in chat box. Everyone understood what I have delivered till now? Okay. So my pace is good. Okay. Okay, let's move forward. Now let's to go to PBFT. So it is an optimized version, or you can say enhanced version of BFT that improves the efficiency and scalability of the BFT mechanism. So how does they do? So nodes go through multiple round of communication to reach consensus. So I'm just giving you the basic overview of this PBFT, how it works and how it basically achieves it, right? So node go through a multiple round of communication to reach consensus, and a leader node propose the block and other node validate it. So a leader kind of scenario comes here, where uh, around the members, around the validator members, one leader was proposed, and he is only able to propose the block to be added or the transaction to be added into a network, right? So this is how the leader is going to do the operation, where in BFT the individual communication was dependent on everyone, right? So everyone has to validate and then validate the proposals based on the mechanism set by the BFT. But here in PBFT we are using the leader kind of approach. So Tendermint and Zilliqa is the example of this BFT chain or BFT network, where these PBFT is where this PBFT is applying. So this is the BFT and PBFT about, where we are handling the fault tolerance, and we are also managing how users are not getting charged for or not getting penalty, instead of getting that what we have encountered in proof of a stake, right, where we have to stake, where the miners or the validator has to stake for the validation purpose. And if they are doing something wrong and something malicious, their token will be locked for permanent period, because they have initiated the transaction which should not be there, right? And that's the problem was there, and everyone wants to be part of this entire communication, entire network communication. But they but nobody wants to nobody wants to lose their tokens or their the identity to be participated, right? So somebody has to be barred from to take participation uh, in the purpose validation processes, right? So Byzantine and PBFT is allowing them to still allowing them to do participation within the validation processes. Now, the next concept here we come up upon is the double spending, right? So, as you know, double spending is a scenario where it basically defining the its this name is defining its operation and its characteristic. So, double spending means where uh, where a digital currency or a currency is spent more than one time, right? So let's say, imagine you go to a shop and pay 100 in cash, right? And once you hand over the note, you can't use the same note again. But in digital system, like sending files or data over the internet, uh, you can copy the files, right? You can copy. Suppose if you want to send your resume to your HR, right? So you are not doing to entire sending the entire data from your computer to that particular mail and deleting, basically cut paste scenario, right? Instead of this, you are basically copying the data, copying your resume and pasting it your email and then sending it to that person, right? So in the same way, when we say send some digital currency over the internet to particular user or particular receiver, a copy of file can be sent multiple to multiple people, right? Unless there is a system to prevent duplication. So double spending is like paying two people with the same 100 rupees, same 100 digital note. Both think that they have received the money, but only one should get, right? Only one will get the ultimate the data and the that particular money, right? So double spending is like the risk that a digital currency or a Bitcoin or a crypto can spend more than once, essentially trying to use the same money twice, right? It is like a duplication of money, which is impossible with the physical cash, but possible in the digital system. Because in digital thing, as I told, in digital scenario, in digital ecosystem, you can copy the digital file and send it to multiple users. Now, why we are understanding this double spending in blockchain scenario and blockchain this course is, so here why double spending a problem. So there are a problem related with that, right? So it leads to fraud and loss of trust. So if you are doing two transaction on one thing, and so basically you are doing fraud with this with the other person, and you are losing your trust. So using this mechanism, this double spending mechanism in digital form, on using your cryptocurrency in blockchain, can can leads to uh, can leads to the users to not use the system and unreliable, right? So leads to fraud and loss of trust. Merchant may lose goods or services if the payment is reversed. So if you are receiving some amount of money from some person, but actually you are like just saying that you receive that money, but in actual term you are not receiving that money into your wallet, right? So you are losing your good, but you are not getting the amount of that particular or the price of that particular good or services, right? Digital currency becomes unreliable if there is no way to stop duplication. So that's why we have to come to an approach where we have to use we have where we have to stop this double spending of things, right? Now, how many types of double spending are there in the blockchain ecosystem, right? So types of double spending attacks are there. How the hackers or the malicious node or the member participant do double spending attacks, right? So we have attack that is known as a race attack. So where a race attack occurs when an attacker sends two conflicting transactions at the same time, trying to spend the same coin twice before either transaction get confirmed, right? So let's take a scenario here. Suppose I'm sending one token to my friend. All right, suppose I'm sending not one token, I'm sending 10 rupees to my friend, and at the same time I'm sending another token, uh, another 10 rupees to my another friend. But before confirmation of the first one, I'm sending within that time frame, I'm sending the another 10 rupees to my friend, right? But as soon as my second transaction get confirmed, suppose one is taking that much time because at that time he was not available online or getting some kind of delayed in the communication system, right? But the second transaction get confirmed over the over the communication process. But somehow I'm spending the two money, two processes and two kind of in I'm spending the 10 rupees in the same scenario within the two process, right? So another transaction using the same amount of money of the wallet and another of to the other merchant. So in within the same time period, that transaction get confirmed, but another the first one is not getting the amount, right? So if second transaction get confirmed first, but the money but already shipped to the product, right? So whatever amount I have send it to my friend, and instead of that I received some product or services earlier than the first one. So there is how this double spending or race attacks works. Within the time frame, within a seconds or within a time that existence of the time, I'm sending two transactions at the same time, right? So what are the risks related to that with the race attack here is merchant accepts transaction without waiting for confirmation, right? So even I'm not even my friend is not accepting the transaction without the confirmation, right? So that could leads to a condition a risk where they can lose their product or the services. So most vulnerable in zero confirmation transactions. How we can prevent it? So always wait for the confirmation once you receive the amount or not, right? The goods is delivered or not, and so on. Use real-time detection systems and the real-time scenarios where the application or the instance or the things that you are using to get the balances or get the amount from the other users. So that's how you can prevent these race attacks. Another one is the Finney attack, right? The Finney attack is, it involves a miner, right? A miner, as you know, who is miner. So it involves a miner who pre-mines a block with coin with a transaction that spends the same coin in a second transaction before broadcasting to the block. How what does it means? Let's take an example. So attacker mines a block. Suppose but whoever is the attacker mines a block, and that includes a transaction A, sending coins to their own account, right? Before broadcasting the block, right? So somehow miners mine that block, and he is not broadcasting that uh, I have mined that block, and you need to confirm that thing before finalizing and adding to the blockchain. So before broadcasting the block, attacker uses the same coin, right, in the transaction B, in the second transaction. So in A transaction, what he does, attacker mines a block that includes transaction A and sending the coin to the other account, basically, right? And in the second transaction, using the same coin, he is doing the same kind of operations. But to buy a product from a merchant in this, but what he did in this scenario, he sends the token to the merchant, not in his account or the other account, right? So after the merchant accepts the transaction B, the attacker broadcasts the pre-mined block in at the time of transaction A, right? The attacker broadcasts the pre-mined block transaction A, which override the transaction B in the blockchain. So how? So the merchant lose the money because in the second transaction, what miner did, miner sent that token into that particular second transaction B, and once the validation takes place by the miners, by the other valid miners, peer miners, and they once they validate the transaction, they will say that okay, this block is already mined and we have to validate. And once it is validated, that whatever amount was received by this merchant will be lost by signing the transactions, right? So what are the risk here is related with that is requires attackers to be a miner. So every attacker should be a miner, but and they have to maintain a full node or the mining node within their system, right? They have to always available on the system. They have always have to available online. Status has to be always active. So these are the requirement to be to attack this Finlay attack, right? A merchant can lose the payments. This is another risk where users lose their payments and all. How we can prevent it? Wait for at least one confirmation while doing the transactions, whether your transaction is validated or not, right? And monitoring the incoming blocks and the mempool transactions within that period. So attackers or the users have to be confirmed by doing by letting know the transactions value, the confirmations value, using any kind of application that is provided by every blockchain network. Now third is vector 76 attack. What is it? So vector 76 attack is a combination of Finlay plus race attack. So basically it combines the both, and it basically providing the targeting the exchanges and online wallets. So it is a specifically to application related things. So how it works, the attacker pre-mined a block same as to Finlay attack, pre-mined the block with the transaction, sending coins to their exchange wallet and similar to Finlay, right? They send the second transaction to someone else and using the same coin, and the exchange confirms despite the attacker's account, right? So exchange confirm that despite the attacker's account, believing that pre-mined transaction is valid. In that process, what how they can lose that particular amount of token, token that has been sent by the attacker. An attacker withdraws the fund from the exchanges and or from the wallet or from the applications, right? So then attacker broadcasts the block with their pre-mined transaction, invalid the second one, and how they are cheating the other ones, right? So basically, they are sending the transaction to the merchant and then finally broadcasting the messages to be validated and get the transactions to be added into a blockchain. So the combination of these two, race attack and the Finlay attack, is addressed in this Vector 76 attack. Our last attack is in double spending is 51% attack. So in every process, whatever we have covered, the race attack, fin attack, and Vector 76 attack, so you have encountered that two times of the transaction is doing, right? Attacker is doing two times of transaction. In 51% attack, what has done here by the miners or the by the attackers is 51% attack happen when a single entity of a group gains control over more than 50% of the network, right? And mining or the staking power can be rewrite the blockchain history. What can like basically they are controlling the entire blockchain's capability, more than the 50%, the majority, whatever we need to achieve for the consensus mechanism and the validation process to be added into a block, right? So basically attackers are controlling the 51% of the authority to handle or to manipulate the data, right? So 50% attack is the very simple, as you know, as I have already covered in the previous one. Now how blockchain prevents this double spending, right? How you can how you can prevent these things to be stopped. So consensus mechanism and the validation process. So when you initiate a transaction, it is broadcasted to the network, right? So you have to broadcast the transaction has to be broadcasted by everyone and at least get the consensus approval on that particular transaction before that you should not proceed for the other another step. Miners and validators verify whether the coin token is already spent or not, right? So basically you have validators or miners verify the token is already spent or not, and that's how they are choosing to do the double spending of the things, right? Once the transaction is confirmed and added to a block, suppose transaction has been broadcasted and you get the approvals and the validations, so confirmed and added to a block, it becomes a part of immutable chain. And once this immutability action is achieved, right, has been processed or achieved, then you cannot change the data, right? Same coin cannot be used again. And as a network reject the duplicate transaction when another person, when the same person is trying to spend the same amount or the same money for the another process, for the another transaction, right? So this is how where we can check the balance, we can uh, stop the things. The other processes are through the time stamping and ordering. So time stamping based on the timestamp of the transactions and unique transactions ID. Every transaction, whenever you do transactions. So in the here the transaction ID, what does it means? Whenever you spend some tokens, that process gets some ID, and based on the ID, you will proceed for the another process. So this transaction ID concept we will cover in the upcoming slides in the today's sessions also. The first valid transaction gets included in the chain, and then the other transaction has to be happen, right? Any second attempt to spend the same asset is marked invalid or rejected. So if the second attempt is spent, the same asset is marked as invalid or rejected, means the inactivity of the state, right? So that's how we can achieve this thing. Uh, hope you have understood. If you have any doubt till now, please let me know in chat box. I'm waiting for 20 seconds and then I can move forward. Okay, let's move forward. Now, how to protect against double spending? So, as you know, we have to approach for some methodologies where we have to implement some kind of processes where double spending cannot be achieved. So, we have a UTXO model where uh, we will cover in the detail what is the UTXO. So, we have two kinds of the approaches or the methodologies where we can prevent the double spending things. The another one is the account balance method. So these UTXO method is applied first in Bitcoin network, and the account balances method is applied on the Ethereum network. So these are two very famous and the basics of double spending attack to uh, to to basically prevent. Let's understand the UTXO is basically what does it means. So UTXO is an acronym for unspent transactions output. So UTXO is similar to physical cash. So understand here is UTXO is similar to physical cash coin based transaction in the real world. For example, imagine a scenario where Alice, I'm taking the very common name in computer science and IT. So example of Alice and Bob. So Alice spends a cash in a shop, right? Gives the entire note she has takes and the goods and takes back the remaining change. If Alice got a chance note of a $10 and wants to buy goods priced $5, she doesn't divide the note in half for the payment. Instead, she gives the entire note and takes the new $5 note as a change along with the goods, right? So let me explain you in a very simple language in the Indian perspective, Indian scenario. So let's say I'm a purchaser. I wanted to buy or purchase some goods. So let's say I wanted to purchase a chips packet, right? So I'm having a 10 rupee note, and I'm having the 100 rupees note, and the chips packet amount is only 50 rupees, let's say. So and I don't have the any changes in my wallet for now. So let's say I'm giving. So I have, if I want that chips packet, I have to give my note to the shopkeeper, so that he can give me that chips packet, and in return he will give me the all other remaining balance of my from my 100 rupees note, right? So what I'm doing here is I'm basically transferring my all money from my pocket to shopkeeper's pocket, and on the basis of the price and the service charges, he is deducting the amount, basically debiting the amount from my balance and returning me the remaining balance of that particular amount, right? So what does it means? Whatever the amount I'm receiving, that is unspent. So I have spent 50 rupees and I did not spend 50 rupees. So unspent transactions, so unspent amount I'm receiving back with my product, with my chips packet, right? So this is how UTXO works. So let's understand in blockchain how UTXO is working and behaving. So let's here I have given an example, right, to a chips packet of 100 rupees. So suppose I'm giving 10 BTC, I'm spending 10 BTC to shop and to purchase some item related which is having the cost of 5 BTC. Now I should have the balance balance a balance of 5 BTC. So I'm taking here example is Alice of I'm an Alice and the shopkeeper is sorry, I'm a Bob and shopkeeper is a Alice. So balance to Alice balance should be 5 BTC, and the amount of this that product is 5 BTC. In the next scenario, what happens is 10 BTC is spent as input and it is giving me 5 BTC in return, and that 5 BTC I wanted to spend another 3 BTC to purchase some other product, and in return I'm getting some 2 BTC in my pocket again. So once the transaction is completed, the shop will have 5 BTC in their account, and the Alice will have the balance of 5 BTC updated in their account. So I'm basically updating my balance, right? I'm basically adding transferring my money to that person and taking back my balances and updating my account, whatever amount I have spent, I have given, I have transferred, and whatever amount I am receiving or credited to my account, right? So this is how UTXO model works basically, right? You spend all the time, all the transactions. Now how it prevents in double spending. So suppose if I wanted to purchase another thing, another product with the same amount, with on the same on the another shop, right? I should have the balance in my hand, right? But what I did here is I hand over my 100 rupees entire note to the shopkeeper. The 10 rupees BTC I have handed it to that shopkeeper, and I don't have balance in my hand and any kind of note in my hand, so that I can go to another shop and want to purchase the same product with the same amount of note, right? So that's how in because whenever I'm spending, the transaction should be validated by the miners in the network, right? So miners, what miners do, they basically check whether I am having the balance, whatever I am spending here is not, is I'm having or not, right? So when they check that, okay, I wanted to purchase some amount, I want to purchase some product, but I'm not having the balance in my hand, right? So because I have already spent 100 rupees on shop A, and on my in my wallet and in my hand the 0 rupees amount I'm having. If I go to the another shop, they will check, okay, you should have 100 rupees or the amount of 50 rupees at least, so that you can purchase that particular amount, particular product, right? So how this works. So what are the advantages of this thing, right? Hope you have understood this concept, the UTXO model here. Let me know if you have any queries or doubt in this. So Harshit, we have covered here the two consensus mechanism, the practical BFT and BFT. So at the end of the lecture, I will also revise entire thing. So don't, no worries. So yeah, Ajay, could you please share what you are not understanding, so I can repeat the things again? So what are the details timestamp included? So timestamp basically include the current time of the transaction that has happened at that particular time. Okay, okay, no doubts as of now. If anyone having doubts, please let me know so that I can cover. I'm waiting for 5-10 seconds, and then if I'll not receive any input, I'll move forward. Give me a second. Sure, Ajay. I'll at the end of the lecture, end of the today's session, I will repeat all the transaction step, the initialization, how the step-by-step process. I will tell you. Is it their personal details or balance? In what the transactions? No, blockchain never stores the personal details, right? And they, in UTXO, balance always maintain and based on the active state of the transactions, right? So that's what I have told right now. If you have any kind of doubt in UTXO, please let me know. Okay, let's move forward. Now, what are the advantages of the UTXO model? So it enhance the privacy. How it is enhancing the privacy? So new address can be used for each transaction, making it harder to track users activity, right? So in the previous slides, I have discussed about this transaction ID. Hope you have remembered, right? So let's here take an example here. So whenever I'm spending 10 BTC to purchase some product or service, right? So I'm deducting my 5 BTC, and balance should be 5 BTC. So this entire process will updated as and it will get an ID of the transaction. So this transaction takes uh, acquires a transaction ID, right? So let's say transaction ID number 1. In transaction ID number 1, I am having the balance 5 and I have spent 5 rupees. In another transaction, right? This is my first transaction. In another transaction, the transaction ID will be updated because the input data is 5 BTC now, and I have spent 3 BTC and remaining 2 BTC. So that is how the in everything, in every transaction, in every process, my transaction ID will be updated based on the inputs I have received. So it is not about the spending the amount, it is also about the receiving amount. So let's say now reverse the process. uh, I'm my balance is 5, and I'm getting 5 rupees again. So my transaction, whatever transaction I have done, or whatever the balance I'm having, so that will updated on the basis of the input of the data I'm receiving, right? So transaction ID is the concept. It has been incorporated in the UTXO model. So every time the transaction ID will be updated based on the transaction that I have spent, the amount I have spent. So in a UTXO model, each transaction output uh, can be sent to a new unique address, right? So every transaction has the uniqueness. Every transaction ID has a uniqueness in their character, in basically in the nature. And even if it's controlled by the same user, you that transaction cannot be tracked for a long time, because every transaction will be updated on based on the transaction inputs. So this practice is called address reuse minimization, right? So whenever I wanted to use that particular amount, it is related to the particular one public private address, but that address of the token has been updated now. Earlier it was something, suppose 123, now the balance has been reduced to 5, now it is 576. So address has been changed, but it is associated with the particular user only, because that user want to spend, and that transaction ID has to be always mapped with that particular user. Hope I you guys have understood this concept, right? So this practical this process is called as a address reuse minimization. So basically, I'm not address using the same address again and again, right? As in the traditional banking system. Whatever amount I am spending using my credit card, the address has always been same, right? But in the UTXO model, in the Bitcoin blockchain system, the address will be changed. As a result, it becomes very difficult for anyone analyzing the blockchain to trace the full transaction history or the total holding of a users, right? Because the transaction ID will be updated again and again, and the total amount of the total balance the user or a particular public address having is cannot be confirmed always, right? So why it matters? So basically, unlike the account model, Ethereum and all, we which have fixed balance tied to single update, right? Single update address. UTXO users can split their asset across multiple addresses for functions, right? This makes chain analysis and identity linking harder, right? Because every time the transaction ID is changing, so based on that, the traceability is very hard. Now the second advantage is parallel processing. So if I wanted to do parallel transaction, right? Suppose I am having the and I wanted to do parallel transactions based on the UTXO model can be spent independently, allowing the parallel transaction validation, which enhances the scalability ultimately. How it is done? Basically, in each UTXO, every UTXO is independent of others and can be spent in the separate transaction simultaneously. So this property allows blockchain system to validate multiple UTXO in parallel, unlike the account model, where sequential check on the balances and the nonce are required. So how it is done? We will explore that part also. In account based model, if two transaction try to modify the same account at the same time, it may use the conflict. But in parallel processing, because every time the transaction is updated, right? So if I'm having the amount in my balance and with the another amount with another address, the same amount I can validate on the same with the parallel processing approach. So why it matters? Basically improves the network performance because you are scaling the process and increasing the throughput of the blockchain network, right? Because the multiple validation process is taking places. Improves the performance and throughput. Foundation for implementing the layer 2 solutions also. Basically UTXO models basically enhance the scalability, so that's the transaction fees and the customers fees will be reduced to a very minimum extent, right? So that's how it works. Now the third advantage is clear ownership. What does it mean? So ownership is associated with the specific output, not abstract balance, making it more auditable and traceable. So UTXO represents discrete unit of ownership. Unlike account models, visibly show which coins are unspent or who controls them. It is easier to track individual coin or UTXO than aggregated amount balance, right? So if imagine I'm spending, in the previous example I have explained, I'm spending 55 rupees, 5 BTC on product and 3 BTC on another product because I'm having the 5 BTC again in my balance. So that's how, and this process is very fast. It takes place within a seconds, right? Ultimately, you are not having. So let's say I'm spending 5 rupees to purchase an item. Within that second, it is not basically showing me the zero balance in my account. In the background, it is behaving as like I'm transferring my whole amount to that particular person, to the shopkeeper, so that he can return me 5 rupees. Ultimately, I'm getting 5 rupees back, but in the algorithm, in the backend systems, it is behaving like the similar thing, similar approach. I'm transferring the whole amount and then returning my getting my the remaining balance in my wallet. And then how I'm spending the same amount, the remaining same amount with the same different address to the other product also. So parallel processing happens within a very seconds, right? It's very fast process using the UTXO models. That's why it is very fast and scalable, and because it increases the throughput of the transactions, right? So it is easier to track the individual coin or UTXO greater than the account. Basically, you don't need to account balance, check the balance of the aggregated amount. You have to just check that okay, this particular amount has been spent by this user, and so on. So each coin movement leaves behind a clear auditable trail because every coin has their own transaction ID and every coin has their own value, which is unique in nature. And so that's how this traceability comes can be addressed, and defines the clear ownership of the coin, right? So auditors or protocol can be verify provenances and ownership lineage regarding the monitoring and so on, so other things. So why it matters? So provides high transparency because clear ownership has been defined using UTXO, and useful for proof of reserve of audit on coin mixing analysis and chain forensics and on all other processes, right? So this is how UTXO is giving the advantage over the other one. Now the fourth one is simple account logic. What is this? UTXO logic is straightforward. Uh, how it is behaving. Inputs are simple inputs are spent and then outputs are created. So no partial balance updated like the account model, right? So UTXO model uses a simple input output based mechanism. You take one or more UTXO as input, create a output, and spend the differences as change. So there is no need to a need for partial balance tracking, right? As in the account model, you have to trace the entire thing end to end. Real world and in real world analogy, like cash notes, right? So you are using what you are you are using the cash notes. You are purchasing some items, and then in return you are getting the balances in your wallet, right? And getting the changes in your wallet kind of things. Basically, the simple account logic. No jargons, or no basically that high tech ideal high tech terminologies is used in this accounting and auditing, right? So simple in wallet logic. So this UTXO model is very useful in while we are integrating with the our Web3 wallets and the dApps, right? Where the transaction are initiating on day-to-day basis for purchasing goods and services over the blockchain network. Eliminates the complex state management required in account-based chains, right? So that's why it is matters. Now the last one is, what is the main advantage here is immutable spend records. So how it works? So basically, immutable spend records, once UTXO is spent, right? So it's no longer valid, reducing ambiguity and the double spending risk. So as I told, if you are using the same amount of balance to spend on a particular thing, so their transaction ID will get changed, right? And if you want to change, if you want to purchase any other item, any other product or services, the transaction ID has been changed. Now that transaction ID has your all the states based on the previous transaction you did. So if you are having 100 rupees and you have spent 50 rupees on particular item, and again you wanted to purchase some item which has the cost of 60 rupees, so you don't have that particular amount in your wallet, right? Because the transaction ID has been changed, and on the base of the transaction ID, uh, the validator node or the network will detect that okay, this particular address doesn't have the sufficient amount, and this transaction cannot be validated. That's how immutable spend records advantages is behaving giving us a benefit, right? So UTXO can only be spent once it is used in a transaction, and it becomes invalid forever. So this gives natural protection against the double spending. The network rejects any attempt of the UTXO that you have done. Why it is matters? Why does it matter? So highly secure by design. Double spending is impossible without controlling the majority of the network, because you have to have the 51% of majority of the network. And the UTXO status, spent or unspent, is binary and easily verifiable. Binary means like you have already know. So that's how the advantages we have addressed. UTXO, why UTXOs are very important in preventing the double spending scenario, and to prevent the network to get malicious the data to be added into a network, right? Now let's go to the disadvantages. Obviously, every scenario has their two faces, every coin has their two sides, right? So as to advantages and disadvantages. Complex transactions managing, because what are those transactions and disadvantages? Let's go through one by one. So complex transactions, right? Managing multiple UTXO can make constructions more complex, especially for wallet. Like in UTXO model, users don't have single balance, right? They have multiple discrete unspent outputs. When making a transaction, a wallet must choose which UTXO to use, calculate the total value, right? Now, suppose uh, I wanted to purchase some item, and I should have the unspent transactions listing in my wallet. Suppose I have 10 rupees, I spent 5 rupees on some item, and I also receive 3 rupees from some users, right? So how much UTXO I'm having in my balance, in my account balance is 5 rupees plus 3 rupees, because I receive also from the merchant, where I have spent my 5 rupees, and in return I get 5 rupees, and I also receive 3 rupees from my one of my account, right? From one of my friend. Now again, I have the total balance is 5 plus 3 equals to 8. Now I wanted to purchase an item which has the cost of rupees 7. Let's say 7, right? Now the UTXO will use the both UTXOs, 5 plus 3. No, in that amount, you have to have the total balance, and the UTXO will be first. UTXO will spend the 5 rupees and then 3 rupees. In that scenario, the entire end-to-end process will happen. So this is how the UTXO model is very complex in transaction, in while doing the transaction using wallet, because they have to take care of the two scenarios and two transaction ID into a particular one transaction ID, right? So that's how it is impossible. That's how it is complex. So as I have given you example, let's take another example. If you have three UTXO, one BTC plus 0.5 BTC and 0.25 BTC, right? So I'm having three scenario here: one BTC plus 0.5 and plus 0.25, and you wanted to send 1.3 BTC, right? Uh, the wallet needs to combine 1 plus 0.5 BTC UTXO total and 1.5 BTC, right? So send 1.3 BTC to recipient, send 0.2 BTC back to the new users, the changed address, right? So that's how it works. Suppose I'm having, now let's take another example in a very simple way here, where I wanted to I have already given an example. I wanted to purchase a coffee which is cost of 150 rupees, and I'm having only 100 rupees in my wallet, and I also receive 150 70 rupees again in my wallet, right? What in background happens, I will enter the amount 150, which in background the blockchain calculate. I have to add the 100 plus 70, and I will transfer this entire amount 100 plus 70 to that user, that vendor, from where I'm purchasing one cup of tea, and within the second of time the remaining 20 rupees I'm getting in return in my bank balance, or in my wallet balance. So users are not interacting with the background scenario, but blockchain is calculating these transactions calculations based on the inputs we have given, using any application, that in case of DApp, or whether it is a DApp or a wallet, Web3 wallet, right? So why it is important? So this complicates wallet design and UX, especially for the new users, and poor UTXO management can happen using in the fragmented balance, because we are using the balances in the fragmentation, uh, where we wanted to buy for some large amount of goods and services there, and there we have to combine all the UTXO and purchase about that particular services or goods. And in that terms, the transaction ID has to be incorporated into one transaction, and gives the one unique transaction ID for the for associated one, right? So this is the one advantage. Now as soon as the transaction ID will be incorporated again and again, for a large transaction, the transaction size will become bigger, right? So bigger transaction size with many inputs and outputs are larger in size, and which basically leads to higher cost of services. So combining if you're combining the more and more transaction ID into one, the miners will take more time to validate, because your transaction, your blocks, your transaction size, your data size is increasing, and it is taking time to consume their resources, because UTXO is a part of the blockchain, where proof of work mechanism is implementing, and the miners will implement, validators will implement, and take their time, run their systems, use electricity, and that's how the transaction cost will be increases, right? So as soon as much as the data is having and the UTXO for the large amount of data, the transaction size will be increases. So more inputs equals to more transaction size, larger size equals to higher fee, network fees, or the gas fee, or you can say the service fee by the platform, right? So what are the impacts it gives? Users end up paying more in the gas fee if they have small UTXO. UTXO fragmentation becomes economically inefficient because it is time taking and bigger in size. Now harder for beginners. So if anyone is beginner in blockchain and blockchain ecosystem and Web3 spaces, they should not use the UTXO model while developing any kind of uh, product or services, or the application, right? Because the concept of the UTXO is less intuitive than simply checking your account balances, right? So users deal with the multiple inputs and change the addresses instead of a single account balance. Beginner may find it confusing when they see difference UTXO in being spent in pieces, right? So users experience will impact, harder to explain, like, but why your balance change and where your change went and how I should receive. So these kinds of the question will arise by in the mind of the users, right? Now the next disadvantage is limited smart contract supports, as UTXO is a model not ideal for the complex logic or the smart contracts or Ethereum. So it is not useful for the uh, smart contract or Ethereum sites. So UTXO model was not designed with the programmable logic in mind, and it supports the simple scripting but lack simple scripting of the things. So Bitcoin supports basic conditions like multi-signature, time blocks, or hash lock, or not full DeFi kind of protocols and things. So complex app like Uniswap, Compound, Aave, DAOs, NFTs are not feasible for directly on UTXO system because it is very complex and doesn't support, because these are applications where the logics and the communication between the based on the predefined sets of logic has to be implemented. So UTXO can be very tedious and like kind of provides very limited support to do these operations. Now, it is less efficient state storage, as I have told. It is as soon as you do bigger transaction, the transaction ID will increase, the block size will increase, and it will take the time. It will take time to implement the things, right? And block size will increase, transaction fee will increase. So it is less efficient, and in that terms. So less efficient state or storage nodes must keep track of all unspent output, which grows over time and increases storage overheads, right? So nodes in the UTXO based chains must maintain a growing UTXO sets database of all unspent transactions of the user's account, and old UTXOs are marked as a spent but not removed from memory until full chain sync, right? So every data has to be in sync, whatever the transaction user is receiving and is spending over the services and goods. They has to have the all the data informations, and every data has to be synced with the another one and the previous one. So over the time, UTXO set becomes large, consuming more disk space and RAM, and so that's why the state storage become inefficient. Full nodes require more powerful hardwares and increasing in entry barriers for decentralizations. And as of 2024, Bitcoin's UTXO set exceeds 80 million entries, requiring several GBs of storage just for unspent coins. So these states has to be maintained. Uh, so before moving forward to the another methodology, that is account balance method, I would request all of you to please go through all the things, all the concepts, whatever I have covered till now, and take a 5-minute break, and then we can continue. And let me know your doubts in the chat box. if anyone having any doubt, please share in chat box. Other than that, I will start again. So let's start. Now let's come to the second approach, how we can handle the double spending using the account balance method, right? So account balance method is a model in which each account maintains a balance and transactions, simply increasing or decreasing the balance in these accounts. So basically, it you can take it as a balance similar to account balance method is similar to how traditional banking system works, right? So if you want to send some rupees, so let's say if you're having balance of 100 rupees and I wanted to send 20 rupees to some your friend or family members, so basically it basically decreases the amount by 20 from your total balance, and then the remaining balance will reflect in your account, and that same amount that has been deducted or debited from your account will be added to the receiver's address, right? Receiver's account. So in the same scenario, the account balances works. So let's take the process how it works. So every user on the blockchain has a balance, some balance, let's say 5 or 10 something, anything like that. So every users have a balance in their wallet application. What they do, as soon as they do transaction, let's say this box has the transaction is describing the transaction based on let's say suppose balance is reduced, like that means I'm sending someone some amount to some my friend or colleague, right? So that balance has been reduced from my account, and now let's say if the balance is increased, so someone has sent me the some balance, some amount of of the tokens into my wallet. So based on the scenario, receiving or sending, my amount will be credited or debited respectively, right? So as soon as the transaction has been initiated from me or from or by anyone, based on the scenario, the receiving and the sending approaches, my total balance will be updated. The account balance will be updated based on that scenario, right? So this is a very simple scenario where account balances behaves and works based on the credit system and the debit system on in the current scenario of the bankings. Now, what is the advantages of the current balances? Advantage of the account balance method. So account balance method offers an efficient, smart contract compatibility and users friendly way to manage digital asset on a blockchain, making it ideal for the modern programmable ecosystem like Ethereum, Binance, Polygon, and any other EVM, or you can say smart contract based solutions architecture of the blockchain network, right? So how it is going giving us advantages. So easy to implement and understand. How it is easy to understand and implementable. So the account balance model works similar to traditional banking system where each user has single account balance that increase, that means credit, or decrease, that means debit with every transaction. There is no need to manage multiple input or output like in the UTXO model, right? So UTXO model, every transaction has their unique ID, and the token will be associated with that particular transaction ID, and then there is a uniqueness whenever you do transactions, but ultimately it was related to your public address and private address it was associated with, right? But in this account balance, this scenario has been removed, and it is very simple to a simple approach to do things. So there is no need to manage multiple input output like in UTX model. So you no need to worry about whether you have sent or receive, right? Your balance will be updated based on the scenario, based on the inputs, based on the calls set up by calls has been initiated by the users. So if you're sending some tokens, then the balance will be reduced. If you're receiving tokens or balance, then balance will be added or increased, right? So you as an example, if you open your wallet and see balance is 5 ethereum, you send 2 ethereum to your balance, become then your balance become 3 ETH. right? It is a very straightforward, like your bank accounts. So benefits are reduced complexity for the valid developers. Any developer or the company or the entity want to use want to make some application Web3 wallets to be used by the users, right? So that will become very easy for them to implement the development things, right? Development environment to integrate with the blockchain and to enhance the user experiences basically. So end-to-end users experience will become very easy and very pleasant and non-complex. Now, second is better for smart contracts and DeFi applications, as it is very easy to implementable. So better for smart contracts and DeFi applications. So in account-based system, smart contracts can store balance, track state variables of any transactions, interact with the other contracts, right? So this make it ideal for decentralized applications, DeFi application, NFTs, DAO, gaming platforms, etc. Because the transactions are very straightforward. You don't need to worry about the inputs and the outputs of the transactions values, like ATX models handles, right? So complexity has been removed, and normal credit based system has been implemented. Credit and debit based system has been implemented. So as we are implementing very simple and manageable approach, so it is also very easy for the application developer or the organization to handle application and the manage the users and the retention. It basically increase the retentions of the users on that particular application, right? So in Uniswap, smart contracts manage liquidity pool, user balances, trade executions. All this possible because the account model allows stateful programming. So in Uniswap, only this account balance approach has been initiated and is implemented. Because it is basically giving the users very simple idea to do operations, and they don't need to worry about this, right? So what is the benefit? So power complexities of the dApps requires contract level accounting, internal balances, and the on chain. So this complexity has been divided from the systems by implementing these things. Now, third is the fewer transaction input equals to faster processing. So as UTXO is handling input and output, and every unspent transactions output balances and the records. So as soon as you are managing all the UTXO within the network, you're basically increasing your transaction size, your file size, and that basically leads to time taking process in proof of work consensus mechanism in Bitcoin network, where users has to validate the transaction based on the whatever data you have initiated for. But in account balances, you are implementing the same scenario using the credit and debit approaches, right? So transaction size become very small, and it becomes very faster to validate the transaction, takes very less size to incorporate into a block, right? So these are the some advantages over the UTXO model, and it basically faster in processing so throughput will be increases based on these things. So in account balance, the transactions only references the senders and the receiver's address, and the amount are listed over there, right? Not a list of multiple inputs and outputs. So this reduces the data size and validation complexities, right? So only the two from this amount has been initiated to where it wants to go. So basic details remains in this particular thing, right? So higher throughput, lower computational power, faster block size, validation, these are the basic advantages of this particular thing. Now let's come to last one, the compact size transactions. So as soon as the compact size, because the transaction contains very few fields like smaller values, to, from, and amount, right? So that's why how this transaction size will become very uh, negligible in size, right? Although it has some size, but it is very less than the UTXO model. So a basic Ethereum transaction include from, to, value of whatever amount you are having. So data, gas fee, that means the transaction fee you are initiating, and the nonce value, right? So nonce value basically, or the validation values basically you are initiating for. So in contrast to UTXO transactions include multiple inputs and outputs with scripts, making them very heavier. This account balance method is very very compact in size, reduce the bloat storage usage, and efficient in frequency, transaction, micropayments, and all, right? So these are the benefits and the advantages of the account balance method. Hope you have understood till now. Please let me know in the chat box if you're having any doubt. Now let's come to disadvantage of the account balance. What are the disadvantages? So lower privacy compared to UTXO model. So because in UTXO model, what we have implemented the transaction ID, where the traceability has been is very complex to achieve, right? Because every transaction has new ID, and because we are maintaining all the UTXOs and all the entries of the token spend or unspent. So in account-based blockchain, all the transactions and balances are linked to fixed public address, right? So that's how it is very easy for anyone to trace that trailing of the all the transactions. Since user typically use the same address repeatedly, it is easy for anyone to track their entire transactions, estimate their total wealth, and the linkage address to the real world. So if I am sending, so suppose I'm sending 10 rupees to someone, I'm receiving 5 rupees from someone. So on, basically related to the same kind of the transaction ID. So why it is problem? So lack of privacy can be concerned. So personal data protection enterprises, where enterprises are using the private blockchain kind of scenario, their the account balances will can lead to a personal data protection, can be very problematic scenario. So higher profile users, enterprise applications will be a problem kind of things. So now let's come to the second scenario. What is the disadvantage of this account balance in the second? So sequential transaction processing, so non-dependency basically. So in account model, each transaction from an account must include a unique nonce transaction account. Transaction must be processed in exact order so that they will fail or get stuck into a mempool, and the linearity of the transaction will be implemented. So slow down the parallel transaction processing, makes transaction management difficult for the wallet and the drafts, because until and unless you are not your balance is not updated, the the other transaction will not be implemented. So based on the previous transaction, it has to be implemented other future transactions also. Now the third one is the higher risk of replay attacks if not handled well, right? So what does this mean? So although nonce mechanism or the validation or the consent mechanism has been implemented, we can implement. Uh, it helps to prevent the replay attack. Some older or cross-chain systems can be vulnerable while doing the cross-chain communication, while bridging, right? So in that terms, this can be a very challenging to handle the things. A replay attack is when the transaction is reused on another network for fork chain, tricking the system into double spending, right? So while doing the cross-chain communication from Ethereum to any Polygon to Binance to any other user, any other blockchain networks, in that terms, this will be very challenging for the developers or the this organization to handle the things, because the double spending will be very easy, because credit and debit based system is being implemented as simple as implemented in the traditional banking system, where the data can be copied and spent multiple times, right? So that can be hampered when this is the special scenario where the cross chain communication is implemented. So that can be we should take care of. Now less suitable for the parallel validations, because parallel validations is not possible because data is in linear form. So every data has to be updated before the next data is being implemented, next transaction is being implemented or initiated by the users. So that's why it is very less suitable. So in UTXO model, independent UTXO can be processed in parallel. But in account model, every transaction depends on the latest state. Also, the validators must process the transaction sequentially. So in the sequentially terms, what does it means? You have to have the previous state as well, and the current state has to be implemented in the current state as well, right? So that is why it is very less suitable for parallel validation. So impact is it create an impact of a limits the horizontal scalability, right? Base layer validations. Validators must wait for the prior state updates before executing the next transactions, right? So because the linearity of the functional linearity in the nature of this count balance method, uh, previous methods, previous approach, previous transactions has to be implemented first, and the next one, and then the further. So that's how they are implementing the linearity, and less suitable for the parallel validations. Now state bloat and storage growth. So as it is linear in nature, since the account model tracks the entire state of all transactions. Smart contracts, and the global state grows rapidly over the time, which must constantly maintain and update the entire state tree. So whenever you are handling the balances in the linear form, you have to have the all the traceability, all the states of the balance information into picture, right? So increase the storage size and requirements, slow down the syncing of the full nodes, and makes node maintenance more resource intensive. That's the main problem of the account balance method. Hope you have understood till now. So in the next slide, we have this model differences. Ethereum uses the account balance model. Binance uses the account model. Solana uses the hybrid account based model, and Bitcoin uses the UTXO model. So every chain has their own mechanism while to implement the transaction processes, where the double spending is being addressed, right? Now let's come to next topic. Give me a second. So let's have a quiz now. So you are having one question in front of your screen. So Byzantine fault tolerance BFT ensures that blockchain network can function correctly even if some nodes act maliciously. What is the minimum percentage of honest nodes required for a BFT based system to reach consensus? Or but and we have the options are 33%. So option B is uh, I think I've uh, marked it as something wrong. Just give me a second. So yeah, so A has 33%, B is 50%, C is 67%, D is 75%. So which one is the correct answer? Okay. So Byzantine, I'm पटेल जी मैं बात कर रहा हूँ Byzantine fault tolerance BFT. So it should have the minimum value of only three answers in 500 participants. Only three answers I'm getting. Okay, we have 50%. Someone says Sushmita is saying A, 33%. Shivaswamy is saying C, 67%. Mohan is saying 33%. Dr. Pahani is saying 67%. Salman Jan saying 67%. So yeah, correct answer is 67%. Correct. Now next question is, how does practical Byzantine fault tolerance, that is PBFT, differ from traditional BFT mechanism? So BFT A, option A is BFT assumes at least 50% of nodes are honest instead of 67%. B is B, option B. Uh, PBFT replaces proof of work with leader-based consensus mechanism. Option C, PBFT does not require a consensus algorithm to reach agreement. Option D, PBFT allows nodes to function without verifying transactions. So which one is correct? think does not require any algorithm. Option C. Someone is saying B. BFT replaces with P of work. B, C, B, B. Okay. Yes, answer is B. Correct. The third question is, what is the primary cause of double spending problem in digital currencies? So options are transactions not being broadcast to all nodes, users having multiple wallet address, the ability, and option C is the ability to create multiple digital copies of the same asset. Option D is the presence of mining pool in the blockchain network. So which one is correct? So multiple digital copies cause double spending. So C is correct answer. Okay. So most of you have answered C. Yes, the correct answer is C. Let's go to next one. So which of the following method helps prevent double spending in blockchain network? Using a central option is using a central authority of validation. Option B, implementing a proof of stake consensus. Option C, recording each transaction on a decentralized ledger with timestamp. Option D, encrypting transactions with the private keys. So which options are correct? Which option is correct? Which of the following method helps prevent double spending in blockchain networks? So again, answer C is correct. Okay. Option A, C, A, timestamps would prevent. Timestamps would prevent. Okay. Okay, B. Okay, so answer is correct. C is correct answer. Now let's go to our last question, fifth question. So how does UTXO model differ from the account balance model? So options are the UTXO model tracks discrete transaction output, while the account balance model updates a global state. Option B is the account balance model uses transactions output, while UTXO uses the balance states. C is UTXO allows multiple transactions from a single input, whereas the account balance model does not. Now option D, last, UTXO is used only in centralized system, while account balances are for decentralized network. So which one is correct? Okay. Yeah. So yeah, Vidushi, you are asking something. I'm getting answer Mohan B, D, Harshit C, SD Patil C. Option A is correct. Okay. Shrikant Bhardwaj ji C. Okay, I'll wait for more last 30 to 40 seconds, and then I'll close this questions, and I will open the your doubts. Still, if you are having doubts, please paste your doubts and questions in the chat box. So the correct answer is A. The UTXO model tracks discrete transactions output, while the account balance model updates a global state, right? So UTXO model is tracks the discrete transaction output basically, right? So every transaction in a UTX model has a different transaction ID, and account balance has the global state where the user's account balance is updating again and again based on the inputs, right? Where if the user is spending or receiving some amount. So this is it for today's session. Please paste your questions and doubts here if you have any questions. Thank you so much, everyone. We are still having 5 minutes, so you can ask your doubts.
So, okay, sir. So there is one update, faculties, like tomorrow we are for Holi celebration. We are for Holi festival. We don't have a session. So, Gaurav sir, like tomorrow, we don't have any session. And Saturday, Sunday will be weekend, right? So even Saturday, Sunday we don't have. Again, the last day, the day fifth session will be on Monday. That is on 17th.
Okay.
So these 3 days, that is Friday, Saturday, and Sunday, we don't have any sessions.
Okay.
Okay. So I hope, dear faculty members, you all got my point. What I said. Like tomorrow, we are for Holi. We are not taking the class, so you all have an holiday by tomorrow. And Saturday and Sunday will be a weekend. So weekends we are not taking any sessions. So the day 5 session is going to be held on Monday at 3 p.m. Okay. So I hope we are done for the day. Sir,
Yeah.
do you have
Thank
any
you.
doubts? No, right?
Okay. Thank you, everyone. Thanks for the today's session, joining today's session. Have a nice evening, all.
Yeah, thank you, sir. Thank you so much. Yes, so yeah, as I told, please join back us on Monday. Thank you all. Thank you for joining this wonderful class. Okay, thank you all. Have a great day. I hope you all marked your attendance. I'll be sharing the attendance link once again on the chat, and we'll wait for 2 minutes. Then we'll wind up for the day. If you have missed out to mark your attendance, kindly mark your attendance. And please don't ask the attendance link after 5:30 or something. As you all know, 5:30 will be the last time to it is a deadline for marking an attendance. Please don't come and message us to share the attendance after 5:30. They kindly mark your attendance right now. I'll wait for 1 or 2 minutes, then we'll wind up. I hope you all marked your attendance. I can see the people are leaving the session. Okay, we are good to go. We will wind up for the day. Thank you all. Thank you once again. Join back us on Monday. Okay, thank you.